Hello everyone, welcome to this video. In this video, we are going to learn about hash table. So at first we need to know what is a hash table. Hash table is a data structure which stores data in an associative manner. Generally stores in an array format where each data has its unique index value. In short, we can say hash table is a collection of data. So what's the purpose of hash table? The main purpose of storing items in a hash table is to find them later easily. So we store some data in a hash table so that we can find them later easily. That is our purpose. Suppose this is our hash table and the size of this hash table is 7. And here we have 7 slots. 0, 1, 2, 3, 4, 5, 6. Here we have 7 slots and these numbers are my index value. Initially, when the hash table is empty, for each index there is a none value because the hash table is empty. Now we need some data to insert into this hash table. Suppose we have 4 datas. 56, 62, 26, 37. We can also call them as key. We need to insert these 4 items in these 7 slots. So how many empty slots will we have? We have 3 empty slots. Now, for inserting these 4 items in this hash table, there is a particular process. Without maintaining this process, we can't add or insert these items into these hash tables. Suppose we can't add 56 in index 2 or 62 in index 3 as our wish. So for inserting, there is a process. The process is called hashing. So generally, hashing means is a process of deciding where to map a given value with a particular key for faster access of elements. That means for inserting these items, we need to generate a hash value that will similar to these index values. So we will do that by using hashing. So the hashing process uses a function that called hash function. So the hash function contains the mode of key and the size of the hash table. For this hash table, this 7 is the size of this hash table. Size of this hash table. And this X means the data items which we want to insert into the hash table. So now we want to insert 56 into this hash table. So for this we need to divide 56 by 7. If we divide 56 by 7, then we will get 0 as remainder. And this 0 will be our hash value for 56. For 62, we get remainder 6 and this is the hash value for 62. As 0 is the hash value of 56, so we will store 56 at 0th index and 62 at 6th index. For 26, if we divided by 7, we will get 5 as remainder and this is the hash value for 26. So we will store 26 at 5th index. For 37, by using the same process, we get the remainder 2 and this is the hash value of 37. So as the hash value of 37 is 2, we will store 37 at second index. Now we will discuss another thing, that is load factor. Load factor is the value of the nth items, the division of nth items by the array size. Here nth item means how many items we have in our hash table. And the array size means the size of the hash table. So for this hash table, the number of items is 4 and the size of the hash table is 7. So for this hash table, the load factor will be 4 divided by 7. Sometimes in hash table we faces a problem. That the problem is called collisions. Collisions occurs when two keys can hash to the same array index. That means, suppose we want to insert another item in this hash table, and that is 35. So to insert 35 in this hash table, we will use the same process. That means at first we will find the remainder of 35. 35 divided by 7. So the remainder is 0, and 0 is the hash value of 35. So as 0 is the hash value of 35, so it will go to the 0th index. Again we want to add another item like 47. For 47 we find the remainder as 5, and it is the hash value for 47. So as the hash value is 5, so the 47 will go to the 5th index. But in 5th index we already have another data, that is 26. So in 0th index and in 5th index we face the same problem. This is the collision where for two data we find the same hash value in the same index. So there are many processes to handle these collisions in hash table.
Previously we have learned about collision in a hash table. So basically collision is two keys resulting in the same value. Now we will look at the collision resolution strategies. For this we have two techniques. One is separate chaining, another one is open addressing. In open addressing we have three approaches. One is linear probing, another one is quadratic probing, and the last one is double hashing. So in this video we will look at on separate chaining and double hashing method. So at first we will take a look on the separate chaining method to see how it works and how it helps to resolve a collision in a hash table. So the idea of separate chaining is to make each cell of hash table point to a linked list of records that have the same hash function value. Now let's take a look on that example to understand more about separate chaining and the process of separate chaining. So at first I have taken these hash keys and I have taken the hash table size of 7. Then I have taken this hash function which is k mod 7. So we have done the division method here. So at first I'm going to take first key which is 15. So 15 mod 7 is 1. So 15 will go to index 1. 47 is my next key. So 47 mod 7 is 5. So 5 was empty. Then that's why I have input 47 here. So 23 mod 7 is 2. 23 will go to index 2. Then my next key is 34. So 34 mod 7 is 6. So I have inserted 34 on index 6. Then my next key is 85. So 85 mod 7 is 1. So now we have faced a collision here. So what are we gonna do is, we will just simply add a linked list over here and add 85 like a chain. That's why it's called a chaining method. So then my next key is 97. So 97 mod 7 is 6. So we have faced another collision here. We will do the same thing. We will just simply add a linked list like that, and we will add 97 over here. And my last key is 70. So 70 mod 7 is 0. So index 0 was empty, that's why there is no collision happened here. So if we take a look on this whole example, it looks really simple. It is actually a very simple implementation. But hash table has some disadvantages too, because if this chain becomes too long, then the search time can become order of n in the worst case, which is not good. Plus it takes more space, and as you can see, those hash tables are empty and we can never really use them again. So it's not a very good option to resolve a collision. So next we will take a look on double hashing method and see how it works. Now we will discuss about the double hashing technique, and we will see how it helps to resolve collision in a hash table. So the idea of double hashing is to apply a second hash function when a collision occurs. So here my secondary hash functions are these two. So the first one, h2k equal to prime minus k mod prime. So here the prime number is less than my table size. So if my table size is 10, so the prime number will be 8, something like that. And my third hash function is h1, which is this, and h2 will be this, and I will be the index number, and mod m, the table size. So now let's take a look at this example and let's try to resolve this problem. So my first key is 96. So 96 mod 10 is 6. So my index 6 is empty, so I will insert 96 here. Then my next key is 48. So 48 mod 10, which is 8. So 8 is also empty. Then my next element is 63. So 63 mod 10, which is 3. So 3 is also empty. Then my next element is 29. So 29 mod 10, which is 9. So 9 is also empty. And my next element is 87. So 87 mod 10 is 7. So this is also empty. Okay. Then my next element is 77. So 77 mod 10 is also 7. So now we have faced a collision. We will try to resolve this by using this hash function. So for that, h2 77. So my prime number will be 8. So 8 minus 77 mod 8. So 77 mod 8 is 5. So 8 minus 5 is 3. So my index 3 is not empty. So now I have to use my third hash function. So let's see what happens. So h3 77. So my h1 is 7. So 7 plus So I will start from 0 index. So 0 into 3 mod 10. So 7 mod 10 is 7. So 7 is not empty. So I have to just keep going. So my next move will be 7 plus index 1 into 3 mod 10. So 10 mod 10, which is 0. So our index 0 is empty, so 77 will go here. Then my next element is 84. So 84 mod 10 is 4. So 4 is empty, so I'll just insert 84 over here. Then my next element is 117. So 117. So 117 mod 10 is 7. So 7 is not empty. So we will just use our secondary hash function, which is 8 minus 117 mod 8. So 8 minus 5, so it's 3. So 3 is not empty, so we will use our third function, which is, so our h1 is 7 plus our h2 is 3, and we will start from index 0. So like that, mod 10. So 7 mod 10, again 7. 7 is not empty, so we will just keep moving forward. Then 7 plus 1 into 3 mod 10. So 7 plus 3 mod 10. So 10 mod 10, which is 0. So our index 0 is not empty, so we will just keep going. Then 7 plus index 2, 3. So 7 plus 6. So 13 mod 10 is 3. So 3 is not empty. So 7 plus index 3 mod 10. So 7 plus 9. 16 mod 10, which is 6. Our 6 index is not empty. We'll just keep going and going. 7 plus index 4 into 3. So 19 mod 10, which is 9. 9 is not empty. Then my next step will be index 5 into 3 mod 10. 22 mod 10 is 2. So my index 2 is empty, so I will insert 117 in index 2. So that's how we solve a collision in a hash table. So hash table may take some time to solve a collision, but it is actually a very useful method because it requires a smaller hash table, since it effectively finds a free slot, and although the computational cost may be high, but double hashing can find the next free slot very easily. So I think it's a better solution to solve or handle a collision. So thank you.